Hello everyone, my name is Shivam Agarwal and this is an introductory video on object-oriented programming concepts in Python. I'm expecting some basic knowledge of Python for you because from the next video we'll be starting with coding itself. This is an introductory video where we will discuss the basic concepts of object-oriented programming, for example classes, objects and various methodologies to meet the OOPS concepts in any programming language. As you can see, I've prepared some definitions here on Notepad and I'll be using OneNote for the explanation also. So without wasting any time, let's start with it. So basically, first we will discuss why do we use object-oriented programming in any language. So basically, when we try to program anything, we can write it in two ways. Either it is procedural programming. So this block generates procedural programming where we have data, we have functions, we have variables, we have strings and everything in a single program. So whenever we write everything in a single program without separating anything, it is called procedural programming. So how is object-oriented programming different from it? So what we do is we take the relationship between the data. Suppose there is a relationship between a certain set of data. We'll put that in a separate column. Again, there is a separate relationship. So we'll put that in a different column. We keep on separating it so that we can define the relationship between different data. And now that we are done, what we'll do is we'll apply a single program to constitute all these relationships. Now these different relationships might be interacting with each other. For example, this relationship might be interacting with this one, but not the upper one. So this arrow denotes a relationship that a single attribute is having with another one. But this one is not having a relationship, but still it is a part of the same program. So this is how object-oriented programming works. Now we'll discuss some basic concepts of object-oriented programming, starting with class. So class is the first concept that we study in object-oriented programming because everything that we do in a language is inside a class. So class is a collection of objects. So what do we understand by this? So you can suppose a class of students. So let us see that this is a class of students. Here we can have different entities. Like we have a table, we have some benches. We can have students who study in the class. We have teachers, we have blackboards and everything else. So everything included inside a specific room is called as class. In programming, what we can say, if we can take some variables, we can take some data, we can take functions and group them in a single block. How do we define the block? By indentation in Python. If we can define a certain block for all these elements, we can say that it has formed a class. Okay, so that is a class. Next is object. Object is an entity that has a state and behavior associated with it. What do we mean by this? So let us understand. In a class, there have been many students who are studying. Each student has one thing in common, that he or she studies in the same class. Other than that, he might have different heights, they might have different weights, they might be having some different subjects as well. But what they have in common is they study inside the same class. So that is an example of objects. So if we can say this is an object of this class and this is another object in this class, what are the common properties of these both? That they study in the same class. And what are the differences? Their height, their age, their weight and their subjects might be different also. So this is what we mean by objects. Next concept is inheritance. This is a very interesting concept. Let us understand it. So inheritance is deriving one class from the another. So let us say this is a father and this is a mother. Okay, this is a father, this is a mother and this is their child. So child has inherited properties or genes from father and mother. Okay, what I'm trying to say is this father and mother, this is their child. Child is inheriting some properties or genes from father and mother. This is also the criteria in classes. Okay, so this might be one class, this might be another class. if there is some class that is inheriting the properties of any of these class or multiple classes also, then we call it inheritance. So inheritance now can be of different types. For example, I have shown you this one. This is called multiple inheritance. So a single class is deriving properties from multiple classes. So it is called multiple inheritance. Okay. This is multiple inheritance. Another type of inheritance is if there is a single class and another single class, and this one is deriving properties from this one. So that a subclass is deriving properties from a single class. So this is called as a single inheritance. Very simple. Single inheritance. Okay. Let us try to reverse this case. There is one class of whose properties is being derived by two different classes. So this is forming a hierarchy, no? This single class is these properties of this class is being derived by different classes. So this is called hierarchical inheritance. This is the third type of inheritance. Okay, grab your pen and paper and try to write all these things. This is multiple inheritance. This one is single inheritance, and this one is hierarchical inheritance. There is one more type of inheritance. Suppose there is a class of whose properties are being derived by another class. What happens after this is we make this class, second class, also a superclass. So its properties are being derived by another class, and the process continues. So you can see multiple levels here, forming a multiple levels. This is called multiple inheritance. Okay, this is multiple inheritance. This is a fourth type of inheritance. These are the major types of inheritance that we use in object-oriented programming. Let us move to another concept, that is polymorphism. So polymorphism is again a very interesting concept. Polymorphism simply means having many forms. We need to determine if given a species of bird fly or not. Using polymorphism, we can use a single function to do it. Okay. So now what we mean by this? So let us suppose that we are making a program for carnivorous animals. Okay. So lion is a carnivorous animal. Okay. Tiger is a carnivorous animal. Yeah, right. Bear is an omnivorous animal. But what do these three have in common? They can eat flesh, right? So these things is common between these three. What we are trying to say is, suppose we have to find whether or not an animal is carnivorous or not. We have to determine three different functions for these three different animals. What we can do is, if we can take out the property and put it in a single function using polymorphism, we can achieve this using only a single function. Okay, so a message that can be displayed in more than one forms, which is achieved by function overloading, which we'll discuss in the next coming videos. If a message can be displayed in more than one forms, it is called as polymorphism. Okay, so there's a lion, which is a different thing, but still is a carnivorous. Tiger is a different thing, still it is carnivorous. Bear is different, it is omnivorous, but as it can eat flesh, it is also a form of display of the same function. So this is how polymorphism works, right? The next concepts are encapsulation and data abstraction. Now some people get confused in this, so try to understand it very clearly. Encapsulation is wrapping up of data. Wrapping up of data, what we mean by this is, we have different classes. Okay, each class can constitute various data variables and functions. Okay, so what data, what variables and what functions have common relationship between them, so that we can put them in a same class? This is determined by encapsulation. Encapsulation basically determines the relationship between data variables and functions, so that we can put them all in the same class. Okay, so this is wrapping up of data. While data abstraction is something that removes the unnecessary code details from the user. Okay, so if we talk about abstraction, there might be some details about a program. For example, in a bank, you can say that details of bank branch or this bank branch, etc., are not to be displayed to every user, right? So this can be hide from the end users. So this is achieved by using data abstraction. What we do is we take some details, make the abstract class for these details, and use some get and set functions to access these functions. Okay, so what happens is, on the other side, where there are users with certain data and variables, are not able to access this abstract class, but this abstract class can always use the functions that are determined already. Okay, so data abstraction is hiding the details from the end users that are unnecessary, and encapsulation means wrapping up of data using the relationship that is determined in between. Okay, so that is how these concepts work. So this is basically the theoretical knowledge. I'll make this large. You can have a look at it, pause and have a look at it, while you can find this online also. Okay, now this explanation is I know it is not very convenient for you, but I've tried to explain it very well. However, if you have any problem, you can always look up to these definitions and understand it. These are very simple definitions. So this is how we determine the basic concept. From the next video itself, we'll start coding, where we'll define the class, we'll define its objects, and use all these concepts to determine how we can utilize this in daily life. Okay, that will be it for today. Thank you.